Hi, this is Seung and I'm the director of Sky Academy, and we've made it to the end of the plane geometry chapter. And as usual, what I'd like to do is give you a summary or an overview of everything that we've covered in geometry. Now, this can be particularly useful for people because oftentimes geometry is one of those topics or subtopics in maths where people get overwhelmed by all the different little bits of knowledge that they have to accumulate and be able to remember, especially because it doesn't really kind of hold together very well. And so what I've attempted to do here is basically give you a fairly comprehensive idea of what you do need to know and what you don't need to know. So here's what we did in this unit of work. We started off with a basic introduction to plane geometry, and we looked at some definitions. Now, we looked, for example, at axioms and theorems, and we worked out that theorems are very useful for us because they help us to be able to build an argument, okay? Use some factual theorems or theorems that are a basis for building an argument because things are true, okay? And so theorems help us to build that argument. Axioms also help us to build an argument, okay? Or build a proof in geometry. And so we looked at the difference between theorems and axioms. We looked at the definitions of some really common terms in geometry, so we need to build a vocabulary there. So for example, we looked at what a point is, what a line is, we looked at what an interval and what a ray is, we worked out what an angle is, right? Which is some basic stuff, but we also built like a fairly comprehensive vocabulary of all the things that you need to know, okay? And so that was a really good introduction to basic geometry. Now, the next thing that we did was we kind of went through episode by episode each of the theorems or axioms that are going to be useful for us in being able to do geometrical proofs. So let me go through some of the axioms that we went through, or some of the theorems that we went through. First of all, we started with vertically opposite angles. So vertically opposite angles was the first one, and we worked out what vertically opposite angles are, and we worked out that they're equal. Okay, so when two straight lines intersect, the vertically opposite angles are equal. The second thing that we did was looked at parallel lines meaning lines that keep going in the same direction, never cross, never touch, keep going in the same direction, right? So two lines that are parallel, and if you have a third line that cuts through the other two lines, that line is called a transversal. And when a transversal cuts through a pair of parallel lines, oftentimes we're interested in the relationships of some of the angles in that set of parallel lines and the transversal that cuts through it. So we looked at particular relationships called corresponding angles, alternate angles, and co-interior angles. Now, corresponding angles we recognize made an F shape, yep, and corresponding angles on parallel lines are equal. We looked at alternate angles. Alternate angles make a Z shape. So if this angle here and this angle here make a Z shape on parallel lines, we worked out that they're equal. We looked at co-interior angles. Co-interior angles make a C shape, right? They're the two interior angles inside a set of parallel lines cut through by a transversal. We worked out that those two angles add up to 180 degrees, and we worked out that the word that we use for adding up to 180 degrees is the word supplementary. So we worked out the co-interior angles are supplementary. Now, after we did that, we looked at some angle properties of triangles. Yeah, so the first one we did was that the angle sum of a triangle is 180 degrees. So we worked out the angle sum of a triangle being 180 degrees. We then, so the angle sum of the interior angles of a triangle, yep. We then worked out that the exterior angle of a triangle is equal to the sum of the other two interior angles, right? So if you've got two interior angles, right, that's going to add up to the complement or the supplementary of the third interior angle, right? And the supplementary of the third interior angle is the exterior angle, right? And that exterior angle is equal to the sum of the two remote interior angles. Yeah. And then we went from triangles, and then we moved on to quadrilaterals, and we worked out that the angle sum of a quadrilateral is 360 degrees, because essentially what a quadrilateral is a four-sided shape, and a four-sided shape is basically two three-sided shapes added together, okay? Two three-sided shapes being two triangles. So basically it's going to be double 180 degrees will be the angle sum of a quadrilateral, which is exactly what we get, 360 degrees, yeah? After that, we kind of looked at some properties of special quadrilaterals, and some of the special quadrilaterals that we went through that we will need to be aware of are squares, rectangles, rhombuses, parallelograms, kites, trapezia or trapeziums, and arrowheads. So we worked out that they're the special properties of the quadrilaterals, and we looked at some of the special properties that each of these special quadrilaterals have, right? So some of the special properties that they have include things like having all sides equal, right? So rhombus in a square is a good example of that. Opposite sides might be equal, opposite sides might be parallel. Diagonals, right? Another property is the properties that come with the diagonals. The diagonals sometimes in some of these special quadrilaterals bisect each other. The diagonals bisect each other. Sometimes they bisect each other at right angles, in other words, perpendicularly. Right? Other times the angles through which they pass get bisected by the diagonals that they pass through. Yeah. Sometimes you look at other angle properties, right? So for example, with squares and rectangles, all sides, all of the angles are going to be right angles, yeah? So yeah, we looked at the angle properties as well, okay? Also, for example, rhombus and parallelograms, the opposite angles are going to be equal, yeah? And then we looked at symmetry properties, right? Some of these special quadrilaterals have axes of symmetry. Some have up to 4, some have 2, some have 1, yeah? So we need to be aware of that. So we looked at the special properties of quadrilaterals, all right? So we looked at triangles, quadrilaterals, and then we also then kind of went on a bit of an extrapolation of this, and we looked generally at polygons. Now, a polygon is a multi-sided shape, right? So we looked at polygons that are not just triangles and quadrilaterals, but we looked at pentagons, hexagons, heptagons, octagons, nonagons, and decagons. Basically, the more sides you have, the more complex the name of the polygon becomes. Yeah, so we looked at polygons, okay? So we looked at the names of the polygons, we looked at the angle sum of the interior angles of a polygon, and remember, there's a formula that helps us do that. We looked at, finding the external angle, the sum of the external angles in a polygon. Ends up being 360 degrees, and we also looked at the internal and external angles of regular polygons, and there's a formula that helps us to work that out. So we basically looked at polygons in one of the episodes, and then finally, before we looked at area and volume, we basically then moved on to congruent triangles. Congruent meaning so it's the geometrical way of saying exactly the same size, exactly the same shape. So we say that numbers or equations are equal, but we say that shapes, right, or that shapes or objects are congruent. Okay, in other words, they have exactly the same size, exactly the same shape. And for congruent triangles, the test was there's four tests that we can employ to work out whether two triangles are congruent or not. And that is SSS, which stands for side, side, side. SAS, which stands for side, angle, side, where the angle is interior or included, the included angle between the two pairs of known sides. AAS, which is angle, angle, side. And RHS, which is right angle, hypotenuse, and side, or pair of sides for one pair of right angle triangles, which may or may not be congruent, but we're testing it out. And if it passes this test, then obviously it will be congruent. Yeah. After congruent triangles, we looked at similar triangles. Now, the difference between congruent triangles and similar triangles is that with similar triangles, what you have is that the two triangles will be the same shape, but not necessarily the same size. In other words, one triangle would be an enlargement or a reduction of the other triangle, right? So one will be a magnification or a minimization of the other triangles, right? And the four tests, right, will be a mirror image of the four tests for congruent triangles, except that you're not looking for the sides to be equal. Instead, what you're looking for is the sides, the pairs of sides, to be in equal ratio to the other pairs of sides. Yes, because we're looking for similarity, not congruence. Yeah, and so you've got SSS, SAS, AA. All right. Now, if two of the angles in a pair of triangles is the same, the third one will automatically be the same. So you only need to show that two of the angles in a pair of triangles is equal to each other. So two pairs of angles, and RHS as well. Okay. So yeah, they're your similar triangles tests. The other thing we then were able to do was to work out that the intercepts of the midpoints of a triangle are going to be in equal ratio. Okay, so in other words, the intercepts of the midpoints of a triangle will give you two similar triangles, right? Where you've got a scale factor of 1 to 2. So the intercepts of the midpoints of a triangle will give you two similar triangles. Now, the other thing was that the equal intercepts on parallel lines will also give you equal ratio. Yeah, and that basically is a corollary to that one there. Okay, in other words, we get this by using this. Okay, we take this one step further. We get this axiom here. And finally, we worked out Pythagoras' theorem. And Pythagoras' theorem, of course, is a squared plus b squared equals to c squared. I know that's just a formula, but what that really means is that the hypotenuse squared, or the square of the hypotenuse in a right angle triangle, is equal to the sum of the squares of the two shorter sides. Yeah? So there's Pythagoras' theorem there. Now, after all of that, the last thing we did, right, was look at area, okay, finding the area of some two-dimensional shapes, in particular quadrilaterals, triangles, circles and sectors, and composite shapes, which are a combination of different quadrilaterals, triangles, and circles and sectors, right? So for example, quadrilaterals, we worked out that the area of squares, rectangles, trapezia, you need to know, parallelograms and rhombuses. Triangles is half base times height, so that applies to all triangles. Circles, the area would be pi r squared, right? Sectors would be a fraction of that circle, right? So it includes quadrants, which will be a quarter of a circle, semicircles, which will be a half of a circle, etc., etc., and composite shapes, which are a combination of working out each of these different shapes and making a bigger, more complex shape out of that, right? So we looked at the area of different two-dimensional shapes, and we also looked at the volume and the surface area of three-dimensional shapes, and in particular, prisms, pyramids, cones, cylinders, spheres, and composite shapes. Yeah, composite shapes being, again, any sort of more complex three-dimensional shape that includes adding any of these together to form a different shape, yeah, or a different object, yeah. So for example, a prism would be the area of the base times the height. A pyramid would be a third of the area of the base times the height. Cone, cylinder, and sphere all have their respective formulas, which I'll put up later. And then you've got the composite shapes. And that basically is a really good summary of the geometry that you will need to know, the plane geometry that you'll need to know for this unit of work in the 2-unit course. Yeah. So if you've got that, you're going to be pretty well right for the 2-unit course. You're going to be pretty sweet. Okay. So let me stand to the side. You can take that all in, but I just want to thank you very much for watching, and I'll see you on the next chapter. Thank you. Bye.